today with Mike MacDonald, CTO, Southeast Asia of Huawei Technologies. Mike, what is ultra broadband and how is it different from the broadband that people use in their home and offices?
Huawei believes that ultra broadband really is the next generation of broadband. We've seen services go from 384 kilobits per second up into megabit speeds, 10 megabits, 100 megabits, up into 1 gigabit per second. So really what defines ultra broadband, though, is more than just the speed itself. There's 4 key characteristics. The first is the speed should be above 20 megabits per second. The second is we're seeing TDM technologies transitioning into IP platforms. We're also seeing, from an infrastructure perspective, copper changing into fiber where it makes economic sense to do so. And then the final point is at the application layer, where previously we would see that the predominant internet traffic was mostly static web content. Now it's evolving into predominantly video-based traffic. And video is a very huge consumer of bandwidth.
What technologies need to be deployed in the access network to deliver ultra broadband?
Well, we really need to make the most effective use as possible with the existing copper plant. So from a copper perspective, we do have copper acceleration technologies, layer 2 and layer 3 DSM, and as well Super MIMO, which allows the user to have speeds in excess of 600 megabits per second. From a PON perspective, we need to have a smooth evolution from existing PON technologies into 10 gig PON and next generation PON. Finally, Huawei's single fan solution allows you to use both copper and fiber in the same access node in a very cost-effective solution.
What about the transport network?
Well, there's really 2 kinds of technologies we see in the transport network. There's IP and there's optical. From an IP perspective, we're talking about interfaces that have 100 gig E-links, 400 gigabits per second slots. We're seeing cluster router systems and evolution to IPv6. From an optical perspective, we're seeing OTN, packet-based OTN, multi-service OTN, and the speeds we're seeing there are 40 gigs and 100 gigs.
What sort of technologies are needed in the backhaul and core transport parts of the network?
In the backhaul, we're really talking about any access technology, anything from microwave, copper, fiber. In addition, we're seeing that evolve to a full routed infrastructure, which means it can support 2G, 3G, and 4G service all off the same solution. In addition, we need to have some kind of end-to-end synchronization, so 1588v2 seems to be the predominant technology there. In the case of the actual core network, we're seeing the OTN again and some of the synergies between IP and OTN, as well as caching to offload the international gateway charges. Really what we're expecting to see is a full 100 gigabits across the entire domain of the access network.
Do ultra broadband networks require operating support software or can they use existing OSS systems?
Well, I think the important thing to understand are the new requirements of the next generation OSS system. Specifically, because of the types of traffic on the network, we need to have tools that can actually troubleshoot IP from end to end, and the best way to do that is with visualized OANM. In addition, video monitoring to make sure that the video application, which will become the predominant revenue source of the operator's network going forward, operate as smoothly as possible. What that means in terms of the solution, however, these traditional management systems maybe were not set up to handle this capability. With Huawei's unified management OSS, however, we can adopt these 2 functions very quickly with just a simple software upgrade.
How can network operators make money from ultra broadband and what sort of services can they offer?
There's really 3 key ways that an operator can make money off ultra broadband. The first is looking at the applications on the network itself and the ability to create a better quality of experience for applications like video going forward. The second is simply a factor of having the additional broadband at their disposal. What that means is the operator can offer high-definition services that maybe previously were unavailable. And then the final is a combination of managed work and managed life. What that means is taking the complexity of the home network and putting the management of that back into the networks that the operator can offer it as a value-added service.
How important is ultra broadband to the development of national broadband?
Well, the future will be built on broadband. Broadband is becoming a critical infrastructure element for countries, much the same way as power or water would be there. In addition to creating jobs, it can also improve education and even drive GDP.
Mike, thank you for sharing your time with us today.
Thank you.